Good morning, dear students. So, last time we were doing symbols of elements. Symbol of elements. Then we have learnt about radicals also. Then we learnt about valency also. And then last class I said you to learn symbols of elements and the radicals. Symbols of elements and the radicals and their valencies in order to write molecular formula of a compound. So for writing molecular formula of a compound, two most important things are symbols of elements or radicals constituting the compound. That means the compound has. Okay? And valencies of the elements or the radicals. Without this, you cannot write chemical formula. So hope you have learnt the symbols and valencies of the elements and the radicals. So today we will be learning how to write molecular formula or chemical formula. So before writing molecular formula or chemical formula for compound, you should know what are the steps we need to follow in order to write chemical formula. They are: number one, write the symbols. First of all, step for writing the formulae of chemical compounds. These are 5 steps for writing chemical formula of a compound. Number one, write the symbols. So first thing what we do is we'll write the symbols. Then number 2, write the valency of the symbols. Then we'll be writing valency of the symbols. Number 3, interchange the valency number. Then we'll be interchanging the valency number. Number 4, write the interchange numbers at the base. Number 5, write the formula of the compound. So we'll learn this with example. Okay, and this method of writing chemical formula is called criss-cross method. So what it is called? Criss-cross method. This is criss-cross method. What is this? Criss-cross method. So this is criss-cross method of writing chemical formula. Okay. Now write the symbols. First of all, let's write chemical formula of magnesium chloride. Chemical formula of magnesium chloride. Okay. So write the symbols. Now in this magnesium chloride, you should be knowing symbol of magnesium and symbol of chloride means chlorine. So you will be writing the first step. You will be writing magnesium and Cl for chloride. Cl for chloride. So first step is you will be writing symbols. Magnesium, symbols of elements or radicals that constitute the compound. That means in this compound magnesium chloride, what are the elements present? Elements present are magnesium and chlorine. So name of the elements or radicals present in the compound. That means magnesium Mg, chloride Cl. Now second step is write the valency of the symbols. Write the valency of the symbols. So in second step, you will be writing valency of the symbols. So this magnesium is cation. That's why I said you to learn table 5.6 and 5.7. So magnesium is a metal. Magnesium is a metal. That means it is a cation. It can lose electrons. So it is positive radical. So cation. That means magnesium valency is 2. Magnesium valency is 2. That means it can be written as Mg2 plus. This is Mg2 plus. Okay. Then chlorine. Cl minus. Chlorine is non-metal. Chlorine is non-metal. So it has tendency to gain electron. That means it is anion. It is anion. So Cl minus means valency is 1. I said you number of charges they carry is their valency. So here magnesium has 2 positive charge, so valency is 2. Here chlorine has 1 negative charge, hence valency is 1. So second step is write the valency of the symbols. So we wrote the valency of the symbols. Then interchange the valency number. Now third step, what you will do? Third step you write here simple magnesium only and here Cl only. Then their valency magnesium 2, chlorine 1. Magnesium 2, chlorine 1. Now you have to interchange the valency number. That means crisscross. Interchange the valency number. So this one comes towards magnesium and these 2 goes towards chlorine. Okay. So write the interchange numbers at the base. Now step number 4. Step number 4, what you will be doing? Write this interchange number at the base. So magnesium 1 and chlorine 2 is going that side 2. So this becomes like this in step number 4. Write the interchange numbers at the base. Okay. Now, if there are numbers which can be cancelled, okay, which can be reduced into lowest term, lowest factor, we have to do. So, but 1 and 2 cannot be cancelled. So you write 1 and 2 only. Then step number 5, write the formula of the compound. Write the formula of the compound. Ignore base number if it is 1. That means we'll ignore this one. We'll ignore this one. Base 1 we'll ignore. Why we ignore this one? Because if we write Mg only, then also it means 1 atom of magnesium. If we write Mg only, then also it is understood that Mg means 1 atom of magnesium. So no need of writing 1. So that means in step 5 what I will be writing is Mg without writing 1. Mg1 I will not write, then Cl2. This is the chemical formula of magnesium chloride. Magnesium chloride. Okay. So let me repeat it again. First of all, whatever chemical compound is given, whatever it is asked to you, means say for example you are asked to write chemical formula of sodium hydroxide. Sodium hydroxide. Then first and foremost thing what you have to do is you just come to know that, you just try to know that what are the elements or radicals present in the particular compound. So here sodium hydroxide. So sodium, and doing this what you can do is in order to know whether what kind of radicals are present. For that you can refer table 5.6 and table 5.7. So just write the compound and go to table 5.6 and 5.7. Basically positive radicals, cations, are written on the left side. Whenever we write a compound, on the left side we'll write cation, on the right side we write anion. So whatever is present on the left side is cation, whatever we write on the right side is anion. That means it will have positive charge and it will have negative charge. In sodium hydroxide also same thing. Sodium is on the left side, so it will have positive charge, and hydroxide is on the right side, hence it will have negative charge. So you just go to table 5.6 and then you start searching for sodium. Then you will see the valency as well as symbol. And for hydroxide you will go to table 5.7 and search hydroxide. You will get a symbol as well as valency. Then in step number 1, what you will be doing? You will be writing the symbol. You will be writing the symbol. Here magnesium chloride. Magnesium is on the left, so cation. Chloride is on the right, so anion. Okay, magnesium Mg and chloride Cl. Then number 2, Mg valency 2 plus, magnesium ion, chloride ion. Now here how many charges are present? 2, so valency 2. How many charges here? 1, so valency 1. Okay. Then we'll come to step number 3, that is interchange the valency number. Interchange the valency number. First of all, you write the symbol without charge, because this charge will make you confused. So just write valency. Just write valency and the symbol. So magnesium valency 2, chlorine valency 1. Just below the symbol you will be writing the valency in step number 3. Then you will be interchanging. That means magnesium now will have 1 and chlorine now will have 2. So magnesium 1 atom, chlorine 2 atom. Magnesium 1 atom, chlorine 2 atom. Then since 1 we can ignore. Why? Because this Mg itself means 1 atom. So no need to write 1. So Mg, then step number 5 we will be writing the chemical formula ignoring 1 at the base. So MgCl2 becomes chemical formula of magnesium chloride. Now we'll be doing this for another compound. The steps are same for writing all the chemical formula. So write chemical formula of calcium oxide. Calcium oxide. Now here 2 parts are there. As I have said already, compound is made up of 2 parts. Compound is made up of 2 parts. One is positive part, one is negative part. One is cation, one is anion. One is basic radical, another is acid radical. So this is basic radical or cation, this is cation or basic radical, this is anion or acid radical. And what is the tip that I gave you? On the left side is always cation, on the right side is always anion. Now step number 1. Step number 1. What you will be doing in step number 1? Write the symbols. Write the symbols. So what is the symbol for calcium? Ca. And what is the symbol for oxide? O. That's it. Step number 1 finished. Then go to step number 2. Write the valency of the symbols. So step number 2. Write the valency of the symbols. So calcium, if you see in table 5.6, you will see Ca2 plus, means its valency is 2. And oxide O2 minus, its valency is also 2 because 2 negative charge, so valency 2. Then step number 3. So in step number 3, what do you do? In step number 3, In step number 3, you will be writing symbols along with their valency at the bottom, below it 2 and here also 2. Then in step number 3, you will be interchanging the valency also. So you just interchange the valence number. Yes. Then in step number 4, what you do? Write the interchange numbers at the base. So you will be writing step number 4, Ca2O2. Ca2O2. Okay. Now, what we can see here? Calcium also has 2 atoms. Oxygen also has 2 atoms. So, do you think 2 and 2 are divisible by by the same number? Yes, it is. It can be reduced. So 2 can be divided by 2. 2 ones are 2. 2 ones are 2. That means it can be written as Ca1O1. Ca1O1. Okay. Now step number 5, what you will be doing? Step number 5. Write the formula of the compound. Ignore base number if it is 1. Ignore base number if it is 1. Okay. So since both the symbols have, both the elements have one atom each, so we'll be ignoring. So we'll be writing CaO. That means chemical formula of calcium oxide is CaO. CaO. Okay. Now we'll be doing another. Now, we'll be doing for zinc hydroxide. Okay. Here also, the compound is made of 2 radicals, zinc being basic radical, hydroxide acid radical. Zinc basic radical, hydroxide acid radical. Zinc cation, hydroxide anion. Zinc is on the left side, so cation, hydroxide on the right side, so anion. Okay. Now step 1 we will be writing symbols Zn, and symbol for hydroxide is OH. ZnOH. And step number 2. Step number 2 we will be writing valency of the symbols. Valency of the symbols. So zinc, if you see in table 5.6, then you will get Zn2 plus. And for OH in table 5.7, you will be getting OH minus. That means here is 2 plus, so valency is 2. And here is 1 minus, so valency is 1. Step 2 is over. Then step number 3. Step number 3, what do you do? Interchange the valency number. First of all, write the symbol zinc and hydroxide OH. Then valency of zinc is 2. Valency of hydroxide is 1. Then interchange. Okay. Now this interchange number you will be writing at the base. In step 4, zinc, here it is 1, so write 1. And OH, you cannot write like this, 2. This means hydrogen is 2, but OH is a group. Radicals are charged atoms or group of atoms. Charged atoms or group of atoms. So whenever whenever there is group of atom, if there is single atom, or if there is a single element like chloride, oxide, fluoride, then you can write directly. But whenever there is a group in radical, whenever there is a group of atoms, then make sure that you will be writing these within a bracket, and then outside bracket you will be writing 2. Zn1 OH whole twice 2. Okay. Then since they are not divisible by any one number, they are divisible by 1 only, so they cannot be reduced. These 1 and 2 cannot be reduced. Hence, in number 5, what we'll be writing is, we'll be writing the formula of the compound ignoring 1. So the formula will be ZnOH whole twice. ZnOH whole twice. This is the formula for zinc hydroxide. Zinc hydroxide. Now, quickly we'll be doing another also. We'll be doing another. That is ammonium sulphate. Ammonium sulphate. Here, can you tell me which is cation or positive radical? Ammonium is positive. Ammonium is positive radical, and sulphate is negative radical. Ammonium is positive radical, basic radical. This is basic radical, and this is acid radical. Acid radical. Okay. Step number 1, you will be writing the symbols. So if you do not know, if you have not learned, then you go to table 5.6 and 5.7, you will get the symbols and the valencies. So symbol for ammonium, NH4. This is group of atom. And for sulphate, SO4. This is also group of atom. So these radicals are group of atoms carrying a single charge. Okay, then step number 2. Step number 2, you will be writing valency. So how can you say? So whatever you see in table 5.6 and 5.7 is NH4 plus 1 positive charge, means valency is 1, and SO4 2 minus. SO4 2 minus means your valency is 2. SO4 2 minus, your valency is 2. Okay. Then step number 3, you will be just interchanging the valency number. So first of all, you write the symbols without their charge. Without their charge, you write the symbols, and then followed by your valency. Here it is 1 and here it is 2. Then interchange the valency number. Now, in step number 4, you will be writing the interchanged number at the base. Interchanged number at the base. So NH4, I said, is a group of atom. NH4 is group of atom. That's why you put bracket 2. And then SO4 is also group of atom. So here you will be writing SO4 1. Step number 4. Then step number 5. If you can reduce, then you have to, but it cannot be reduced. So write the formula of the compound ignoring this one. That means it becomes NH4 whole twice SO4. If you ignore 1, then this will come out of the bracket. So this is formula for ammonium sulphate. Now, my dear students, hope you will be trying this activity number 2 in your home. This will be homework. Activity number 2 will be homework. You will be practicing how to write chemical formula following these steps. then we'll be learning, we'll be knowing now what is the significance of a chemical formula. The significance of chemical formula or molecular formula. So, if I write this is chemical formula of ammonium sulphate. Now, if I write this ammonium sulphate only, then I may not be getting idea about what are the atoms, what are the different elements present in this particular compound. I may not be knowing. But if I write molecular formula, then this molecular formula means one molecule. It represents one molecule of the compound. It represents one molecule of the compound. So NH4 whole twice SO4 means one molecule of the compound. If I write MgCl2, this is one molecule of magnesium chloride. This is one molecule of magnesium chloride. Number one importance of chemical formula, writing chemical formula is, we will come to know that this means one molecule of particular compound. So this is one molecule of magnesium chloride, this is one molecule of ammonium sulphate. Not only that, we will come to know how many elements, what are the types of elements present in a particular compound. So here, what are the elements present in magnesium chloride? Magnesium and chlorine. What are the elements present in ammonium sulphate? Nitrogen, hydrogen, sulfur, oxygen. And not only about the different types of elements present in a particular compound, but also how many atoms of different kinds are present in a particular compound. So you can see here how many atoms. Nitrogen, 2 atoms. Hydrogen, 4 2s are 8 atoms. Sulfur, 1 atom. Oxygen, 4 atoms. But looking at this name only, you will never come to know about number of atoms of a different elements. So here also we can come to know that, okay, magnesium chloride has one molecule of magnesium chloride has one magnesium atom and 2 chlorine atom. So in this way, these are some of the significance of molecular formula. And from these molecules only we will come to know about molar mass. Molar mass. So what do you mean by molar mass? Molar mass means mass of a molecule of a compound. Molar mass means mass of a molecule of a compound. So we can calculate molar mass of a compound by knowing its chemical formula. For example, molar mass is mass of one molecule of a compound. So what is molar mass? Molar mass is mass of one molecule of a compound. For example, molar mass of magnesium chloride. Molar mass of magnesium chloride. Now before learning how to write molar mass of a compound, you should be knowing atomic mass of a compound. So what is atomic mass of an element? Atomic mass is mass of one atom of an element. So before writing molar mass of a compound, you should be knowing atomic mass of an atom of an element. So what is atomic mass? Mass of one atom of an element. For example, atomic mass of, so whatever you feel like writing, either AMU as atomic mass unit or U as unified mass. So atomic mass of magnesium is 24 AMU. So regarding atomic mass, you can refer table 5. Okay, you can refer table 5.8. So regarding atomic mass of elements, you can refer table 5.8. So knowing atomic mass of an atom of an element, you can write molar mass, because molecule contain atoms. Molecule contains atoms. Molecules are made up of atoms of same type or of different type. So before writing molar mass, you must be knowing atomic mass. Now molar mass is mass of one molecule of compound. For example, we have, if you want to find magnesium, a molar mass of magnesium chloride, then you can write here solution name of the compound, magnesium chloride. Name of the compound, magnesium chloride. And number 2, chemical formula of the compound. So what is the chemical formula of the compound magnesium chloride? Yes, we have wrote the chemical formula here only. So what it is? It is MgCl2, magnesium chloride. Then you can write molar mass of magnesium chloride is equal to how many atoms of magnesium? 1. So 1 into atomic weight of magnesium, plus how many atoms of chlorine? 2. So 2 into atomic weight of chlorine. That means we have to multiply atomic weight by the number of atoms. Then 1 into, what is atomic weight of magnesium? 24 AMU. So you can write 1 into 24 plus 2 into, what is atomic weight of chlorine? If you refer this table 5.8, you can come to know that atomic mass of chlorine is 35.5 within bracket. Okay, then 1 into 24 plus 2 into 35.5 is 71 makes 95 AMU. So molar mass of magnesium chloride is 95 AMU. In this way, by using molecular formula and atomic mass, you can come to know about molar mass of the compound also. Okay, so at home you will be doing activity 2 and activity 3 as homework. So till then, this much for today. Thank you.